Ionic equilibria. Ionic equilibria, when we talk about it, we think about the process of solvation. Like other reversible and chemical physical changes, tends towards an equilibrium. At ionic equilibrium, the rate of solute dissociation equals the rate of precipitation. So we can think of AgCl, for example, AgCl solid in an equilibrium with its ions Ag plus aqueous plus Cl negative aqueous. So this is going to be the dissociation if we write it out in an expression and into an equation. So now to figure out KSP, which is the solubility product, this gives us information whether a system is unsaturated, saturated, or supersaturated. KSP we can figure out by multiplying the molar concentrations of the constituent ions of the ions that we have raised to the power, their stoichiometric coefficient. So these coefficients that they have, which is 1 and 1, are going to be the powers that we have. So sort of related to the other constants that we've been doing. So Ag plus raised to the first power times the concentration of Cl negative to the first power. And so that is our equation for that's what we have for KSP. So sometimes we have Q, which is the ion product, and if we have a Q based on the concentrations of Ag and Cl negative, we can tell whether something is saturated, unsaturated, or not, or supersaturated. So when Q is less than Ks, or KSP is greater than Q, we know that it's unsaturated solution. It's an unsaturated solution. If Q equals KSP, then it's saturated solution. And if Q is greater than the KSP, then we know it is supersaturated solution. So the KSP, the solubility product constant, can help us understand whether a solution is unsaturated, saturated, or supersaturated in ionic equilibria.